Okay, today's problem is like earliest finish time for land and water rights part 1. I'm doing the solution for this part 1 and part 2 for both cases because both are the exactly same thing. I'm coming to the solution later, but the thing is the problems are exactly same, only difference in the constant. This is 100, this is 10, 5 into the power 4. That's all. So as I'm solving this problem, it will automatically solve this problem. So because I'm not just looking for that only for solving this easy problem. I'm okay. So let's start. What is given? So you are given two categories like of theme park. Like if you want a theme park, you can go Disneyland and anywhere. If in the Wonderla, anywhere place, you can get the two kind of rides. One is land rides and one is water rides. Okay. So what is given in the land rides? For the land rides, there are two set of arrays are given. So for two set of arrays, what is said? That is one is land start time. So this is the earliest time that ith ride will be can be boarded. Okay, and duration, how long the ride lasts. That's the duration thing, how long the land ride lasts. Okay, so let's say this is my land ride 2 and 4. It is the land start time. I'm writing at LAST, land start time, and land duration. Okay, so that means it is, let's say, 2 and this is 1. So each, this means this is one ride, this is ride number 1, and this is ride number 1, this is ride number 2. That means the ride number 1 will start at the second 2th time, 2th unit of time. It will be 2 hours, or you can say it is starting from 2 p.m. or it's starting from 4 p.m. Yeah, that depends. Okay, so anyway, this is the first time it will start. So this is the 2 time it will start. Let's say 2 unit any time. So in this 2, at 2 it will start, and it will long, like it will take, let's say, 2 minutes. So 2 hour 2 minutes it will take. So whatever it is the unit of time. You can take any unit as your according to you. But for this one, what is saying, like ride will start. This fast ride will start at 2 and it will take 2. So how long it will take? 2 plus 2, 4. 4 times, and at that time 4 times it will, this may start. Okay, so 4, it will start at 4 and it will start for 1 duration is, so it will be 4 plus 1, it is 5. Okay, so this is the land right. Same for the water right. So water start time is y, water start time j time right can be boarded, and water duration, the like how long the j water ride would last. This is the thing. Okay, a tourist must experience exactly one ride. I don't know which water park gives this kind of thing or theme park gives this kind of thing, but the thing is the tourist can experience exactly one ride from each category. Okay, so now the conditions are a ride may be started in its opening time or any later time. So that means start at 2, it could start at 4, it can start at 15, anytime. Okay, if a ride started at the time t, it finishes at duration t plus duration. That's what I'm saying. Like if we start from 2, it will finish at 2 plus 2, 4. 4 unit of time. Okay, so immediately after finishing, let's say this is the water start time. Let's say water start time is nothing but, let's say, 3 and 4. Okay, and water duration, this is WD means water duration. Water duration, let's say 1 and 5. Okay, so I can start from here 2 4. Okay, and 2, and I can do this route. It will take 2 plus 2, 4 times, and this same amount time, in the same time I can write this one because it is starting at 4. So I can run this kind of thing. So I can board on this ride at the same time because it is ending and it's ending. So the thing is, what I could do again, so it is starting at 2 and 2 it will end at 4. But see, 3 is also available in the by name. So I can, if you wish, you can run at the 3 as well. Okay, so you can run as a 3 as well. So this is the thing, you have to look into it. Okay, so and immediately after finishing, this is the meaning, immediately after finishing one ride, tourist may board other ride if it is already open, or wait until it opens. That means, let's say it is 5. Let's take a good example there. So let's take only 2 here. 2, and it is, let's say it is 4. It will end time is 4. 4, and water time start time is actually 3, and let's say it's 5. Okay, 3 and it ends at 5, and 3 ends at 5, and here it is, let's say it is starting at 3, sorry, 3 and ends at 5, and it start good at 5 and ends at 2. Okay, anyway, I shouldn't remove this thing, whatever. So the thing is, I will explain one by one. So this is a could be case. Let's say this 2 I'm adding first. 2 plus 4 is 6. Okay. 2 plus 4 is 6. So let's say, okay, I'm giving a wrong example. Can take 6 here or 7 here. Okay, so 6, so this water time is 7. So I can write this one. It will take me 2 plus 4, 6 unit of time. After 6 unit of time, this will open at the 7th unit of time. So I can either, this is already open 3 unit of time. That's why I'm writing that time. This thing I'm writing that in that moment when it is open. So I can either write this one or I can wait to, I can write this right. So this I could do. Okay, so this is what it is meaning. Fine. Okay, so then what is the case? So that is the case. So now this is return the earliest possible time each student can finish both of the rides. So the student is in a hurry, so he has to enjoy as well, but has to do this enjoyment within the as possible as soon as possible. Okay, so that's why the tourist in a hurry. So he want to finish both rides within a minimum possible of time. Okay. And this is how we want to solve the problem. Okay, so how could we solve or could we see, solve this kind of problem? Let's see some test cases first. So, let's see some test cases. So nothing I want to mean to say. Let's say my land start time right now having only one thing, that is two, or maybe something, or leave it. I'm just giving you the edge cases first, then I will give a proper example. And land duration is nothing but that is my 4. Okay, now this one is another one is water start time. Let's say that is but 3, and water duration is nothing but let's say my 5. Okay, so what actually can be done? I can start this one first or this one first. So you can say minimum like this is time is early, so I can start this one first. But doesn't matter. So the thing is, uh, time is not a case here. Like I will give you an example where you can understand the time. We shouldn't look at the time, because if you look at the time, it will you have to take multiple if else statements. So I want to give a generic case. It will be best for every cases. So for now, think of these as a pair. Like I'm in a entire list, I'm choosing this element, choosing this element. Okay. So see what could it be done? Like if I write this one fast, how much time it is takes? It takes 2 plus 4, 6 amount of time. Okay, 6 unit of time. After within this 6 unit of time, my water right is open. My water right is open. That means I can take like then I can do this 5 amount of time. So 6 plus 5, that is nothing but 11. Okay. What if this instead of water right 3 and 5, it is given 7 and 2. 7 and 2. So that time what it will take? So first time 2 and 4 again 6 amount of time. But see here, I have to wait for one time. I have to wait for only one time. One time because it is not started yet. It is not started yet. I have to wait for one time. So I want to wait for one time so that it will start. Then I can do this what? Plus this 2 amount of time. So it becomes 7. Then I can start this. This is my 9. So see, there is actually pattern. I want to show you one pattern. Pattern is like, so this is here. In whenever I got this output, so in this case, what is my 9? Where is my 9 coming from? You can say 7 plus 2. So 7 plus 2 is my case. It doesn't depends on my first right. 7 plus 2, it is depends on 7 plus 2 because 7 is the maximum. So that time, in this case, when it is started, it is starting with what? 6 is the case. 6 is the case. So 6 is the maximum in this time. So 3 is smaller than this. So I am doing the summation of this. If I am pairing, just think of it. It is not about whole array. I am just picking random elements. Random, like that is something is there. Let's say item is 2, 3, 7. Something I'm adding is random. Let's say 4, 5, 6. This is for start time and land duration. From this entire row, I'm picking one case. This is the one case. So I'm comparing between two pairs actually. You can think of it. Okay, so what is happening here? Remove. So okay, so what is happening here? Here 2 plus 4 is 6. So here what in this pair it is 3 comma 5. 3 comma 5 or 3 and 5. Start time is 3 and water start time is 3 and duration is 5. So this here 6 is actually greater than my 7. 3 greater than my 3. So from this thing I am getting 6, and maximum is between 6 and 3 is nothing but 6. So that's why I am taking 6. Okay, and adding the duration. Correct. Okay. Now, if I instead of this pair, I am looking for this pair. So within this pair, this is the maximum and this is the maximum. Okay. So in this maximum, what is the maximum? This is the 7 is the maximum from 6 and 7. So I'm taking 7. I'm adding the 2. That's simple. Adding the 2 and this answer is 9. That's all. If you have to compare two pairs, then I can. How can I get this thing? Okay. Now this is the thing like. Depends, like it depends on how you are doing for LSU. Think of it, this is given here and this entire thing comes here. So instead of WST, instead of WST or WD, water start time, or let's say this is our water start time, it is our water duration, this is my land start time, and it is my land duration. Okay, that time I have to do the same calculation for this one first, and then I can do this calculation. Correct. Then I can do, oh, like let's say this is my water start time, so that time I am doing 4 plus 2 for the water start land start time. Now I have to do this 4 plus 2 for the water start time, so I have to check twice, like once for that I am riding the land first, then I will ride my water, or I will ride my water ride first, then I will board the land ride. That is the single case I want to check, like two cases I have to check. So here you can argue like, instead of doing this kind of two step, I can do if else. You can argue with that. Say, bro, if you are doing if else, then also I think two line of steps, right? That's why instead of if else, we can write this whole calculation. This is nothing but if that is, if you're comparing, this is smaller or greater than this, and this is smaller or greater than this, you are comparing with that, then you are doing equals. Like you can say like whatever, if I am comparing two pairs, if I comparing two pairs, like it's a 2 and 4, so comparing this pair with this pair, whichever having the smaller start time, I will start it fast, then I will board that, like what is the less start time. Okay, in that case you are writing this condition, like if my start time, let's say this LST is less than my WST or the start time, then I will start this one line of code. Else, otherwise I will sum up this line of code, this line of code. So again, it's the same thing. It's a kind of a one step of just adding two numbers, right? So that's why it doesn't matter. So whatever you start first, then you have to, if you do this thing as well, then also you have to compare thing with what is the maximum. Like this thing I explained. This is the maximum. So 6 and 7, which is the maximum, 6 or 3, which is the maximum. So then you have to compare and add it. So that's why it is a one liner of statement. You can directly do that, and you can solve this problem. Okay. So that's what I'm saying. So what we could do. So this is what. So each pair you can calculate. So each pair we can calculate once, and then we can say what is the minimum of the both two pairs. Okay. We can say what is the minimum of the both two pairs. So let's say this is the case. Let's remove this one. So, or let it be. So if that is the case, what is my condition? If I have to check only two pair, let's say my two pointer approach, you can say like I am for each, and like there is a LST is the list. Okay, LST is the list. LD also is the list, correct? And WST is the water start time, another list, and water duration is also another list. So what I can do, there are, let's say something is there. These four items are there. So these four items here, let's say the three items are there. Okay. So what we could do, for each one pair, I can compare one another pair. So I can compare this pair. I can compare this pair. This is a brute force approach. Then again, I can come here. I can compare this pair. I can compare this pair. I can compare this pair. And again, for this pair, I'm going to compare this one. Going to compare this one. I'm going to compare this one. For this, I could do. I could do. So in this case, whatever is the minimum, I can take that one. So I'm comparing each and every pair. Like if I do this one, then what will that, if I do this one first and then this one, So what is the case? So as I said, like when I'm comparing both ways. This one, when I'm comparing these two pairs, first I'll check this one first, this was second. Next comparing this one first, this was second. This is how I'm going to compare. Okay. So so simple brute force approach we can solve, like we can do for this. This is a very small basic problem. So for this easy thing we can do this brute force and it will automatically pass, because it is very number is very limited. Okay, one thing I forgot to tell you, like start time length and duration is also same, and what are start time length and what are duration is also same, because every write is a start time and every write there is a separate duration. So that's why their length is same. So if I want to solve the problem for the smallest problem, and let's say using the brute force, so then what is the our pseudocode? What should I look? Okay. So as why I'm checking for each pair. So let's say function is, let's say, minimum time I am to find. What is given us I'm writing the short form, please don't mind, this is very lengthy to write. There is land start time, land duration, water start time, and water duration is given. Okay, so what I can do, I can initialize my result, or a time required, let's say time required, that is nothing but my infinity. Let's say my infinity, I'm taking a maximum number, it is an infinity number I can take. So right now what I have to do, I have to run a for loop. So for my I starting from 0, how much time? I less than my length of lst dot length, so that every item I want to iterate, then I plus plus. Okay, fine. And for same thing, for how many, for each case it will nested loop I have to write. For each I am iterating, I'm checking for each j, so that's why each j equals to 0, j less than water start time dot length. You can do water duration and dot length as well, because both are same. And j plus plus you can checking. Now what actually you are checking? As I told, I have to check two pairs. Let's say I am doing my land first, land right first. Okay, so I am writing the land. So land first. If I'm doing my land first, then what I have to actually do, I have to, each pair I have to calculating my land first. So LST of I, what is the time if I have to do the land first, cover the land first, so then I have to, that this is the pair. And now think of I'm doing the each pair. This is what I'm doing. This is what I'm doing. This is the each pair, right? This is I'm done for the each pair. So that's why I need this summation, right? So that's why when I'm doing land fast, then I'm doing LSTI plus LDI. So that's what I'm doing. So I'm doing this one and the summation of, and then I'm comparing the maximum. That's why land start time I and ith position plus land duration of the ith position. Okay, that is what doing. Then what I am checking? Then I am writing my water. So last water last. So in that case, what should be my start time? So I told you maximum of previous, that is my land first time, comma, what is my water start time. What will be the index? J, because I is pointing my land right, I is pointing my land right, and J is pointing my water right. So that's why water start time of J. And what will be the thing? It will be, I am going to add at the end water duration, because I'm starting water, right? So water duration of J. At the end, result will be what? Result will be, what is the minimum? Minimum, it could be my result is the minimum. I'm checking the previous result. It is not result, I'm doing a time required, or let it result, it will be smaller. It will save me to time to write it. Why it is not removing? Let's remove. Let's say result is infinite. The previous result, comma, current water, if I water last, if I write water last, this is the time. Okay. So if I don't do the water last, if I do the water first, same thing will be written. Just I will Okay, let me write. If I do water first. So if I do water first, let's say water first, what will be the case? So that time I'll add water start time of I plus water duration of I. Okay. And if I that time if I do the land last, so land last, that will be a maximum of my water end time, that is nothing but water if this is nothing but my water end time, right? This was earlier, it was my water land end time. I'm writing the land first. It is my land end time. So I'm writing the what is the land first means this is storing my when my in this pair when my land ride will end. Okay, here it will be when the water ride will end. This is water first. So this is just so maximum is water first. So water first. Then what is the start time of the land? So land start time of the, okay, I did a mistake here. See, I told you water will be the J. It will be very common mistake. So what J is pointing the water right. So it will be J, not I. Okay. So land in the case. So water is storing the water when the water right will end. So I is comparing the land start time of I. I is pointing to the what is, as I said, the land rides plus, which is the maximum, the LD, land duration of that I. Then what will be the result? Result is nothing but minimum of previous result or this my land last. Okay, whatever the result is. So this is how I am comparing each and every pair, and at the end I will return result. Simple. I'll say return result at the end. And this ends. So it will pass. See, here I am comparing each and every pair. Every possible case I am comparing. So nothing could be better than this. Right? I can say in the time convention, nothing could be better than this in terms of comparison. Okay. So there's a reason I am doing this result. Okay, fine. And what will be time complexity for this? It is a big of n, m. Let's say first is a big of n, and this is big of n. So that is nothing but big of time complexity will be big of m into n. M is the length of, okay, what is given here, na? Okay, land start time is big of n, it is given. I don't know why they prioritize n before m. For I always prioritize m before n. So I write this is n, this is m. So time constant big of n into m. Space complexity. Are we taking any extra space to storing this thing? No, apart from those extra variables. So it is big of 1. Okay, so this is a simple solution for this today's problem actually. This is the case. So let's optimize this thing. It will pass, but this thing it will not pass. So it could be tomorrow's problem or anyway. Like it is a big of m into n. This is like from n square time complexity. So that's the reason I am actually thinking of a better solution so that we can optimize this problem or not. Okay. So what we could do now? Let's see a good proper example to solve this so that you can understand. Okay. Let's say my LST is nothing but LST is nothing but 2 3 2 3 3 4. Okay, let me pause and write this. We'll save some time. Okay, this is my LST. Let me land start time, land duration, and water start time and water duration. Okay, so for your understanding, I am writing in a small, like in a single row. Let's say land ride. So this has been 2 comma 15. I am writing this way. So I'm writing in a pair for your understanding. I'm not going to do in the code. So you understand I'm writing. So 2 comma 15 will start at 2 and end at the duration is 15. Then 4 comma 2. Then 3 comma 3. Then so that means this is our taking 4 2 3 3 3 4. That's what I'm taking. 3 4 and 17 1. Similarly for water rights I'm doing that. For water right it is nothing but 118 3 5 5 3 5 3 Then 355 Okay. So here, see this. In this problem, now see the problem is my tourist wants to do one thing. The tourist want to do to save the time. He wants to complete the minimum time. So what we start do? He can actually calculate the time it is taken. The calculator the time. So one ride takes how much of time to start to complete. See here, to complete this thing, he needs how many time? He needs 17. Okay, he needs 17 because ride start 17 unit of time because ride start at 2 and to complete the ride it is 15 unit of time. This is 17. For this, how much it will be taking? 6 unit of time. It is 6 unit of time. This is taking 7 unit of time. Okay, so it is taking 7 unit of time. So again it will taking 18 unit of time. So okay, for this one how much it is? 19 unit of time. It's 8 unit of time. It is 8 unit of time. This is 8 unit of time. So if a tourist want to save the if you are the tourist and you want to save the time, you obviously look what are the rides and what are the rides it will take as minimum of time. Okay, you can do this one and this one. There could be another case as well. Let's say okay, fine. Because if you are thinking like, see here, this one is taking a minimum of time. Okay, one. But see, here, start time is very late, so that's why it's taking more amount of time. Even if it is a very less amount of time, just only one amount of time to finish the ride. Okay, so obviously, if I have to look, this is the that unit of time. This is unit of time. I have to wait or I have to spend to complete the ride. 6 unit of time within 6 unit of time it will be end. So you can think of it in a zeroth scale. So you can think of this in a scale. Let's say it is 0, this is 1, this is 2, this is where you can think of it. So this is the 6 unit of time. It will say something in here. So this ride will compare in far later than this time unit of time. So this 6 is nothing but just for, this is not just of duration. This is not the duration. This is this 6 7 or what I'm saying, these things are present when my rides actually end. If I board on this ride, when I can board down, I can come down from that ride. This is a 7 unit of time I can finish the ride. This is a 6 unit of time I can finish the ride. Okay, so in that time I can finish it. Then after this, after I finish this, then I can think of, I can after this 6 I can start here, I can start here as well. So this is depends. And this 3 you can start this ride as well, you can start this ride as well. In two cases, see here in the water ride also, this is a 9 unit, this is 8 unit, this is 7 unit, this is 8 unit of time. So if you want to save your time, your optimal, obviously you look for land ride, you can look for these land rides, and for water you can look for these land rides, right? Sorry, water rides. For this water you can look three, you obviously not think of this one because I have to save time as soon as possible. And for land race I have to finish as soon as possible. So these two, for this thing now, see, for this combination, for each combination I have to check right now. For each combination I have to check. So see, these are the minimum, so this is the each combination I have to check. But see here, it is now, it could be another problem because see here, let's say everything is 20 here, everything is 20, everything is 20. If that is, if I'm doing the same thing for each minimum of that, like we have, if you now you can think of this way, like for each minimum from this, okay, I'm checking for what is the all the minimum possible from here. You can think like question can be given everything with the same range. This duration is kind of same. Let's say this is, let's say this is 20, it's a 515, this is 14.6, let's say 317 kind of that. So everything is 20, 20, 20, 20. So and everything here, let's say it is 8, 8, 8, 8. It is, let's say it is only 7. It is 8, 8, 8, 8, 8, 8. So then each every pair, we are actually comparing each and every case. It is similar to the first case. So we can't compare each and like, you can think I can sort out the smallest time. What are the pairs I need from the smallest, and so what are the smallest pair to finish the ride. We can sort out those things, filter out those things. Then I can compare. I can filter out from the water ride as well, and then I can compare each and every cases. So worst possible case, it could be that every ride could take the same amount of time. Like not same amount of time, duration could be different, but at least the final outcome, final when the ride ends, That will be the same for every cases present in the each rights. Okay, so we can't do this thing. What we could do, even though what we could do, I know this is 8, this is 8. That means what? I can start any of those. I can start any of those. It will take 8. Okay, it will take 8. And then I can think like, so at the, it will take 8 at most, then I can think of it. So that's why I told you, like, you cannot just compare. In this case, I told you, na, you cannot just compare these two cases. Like, if it's 2 and 4, then I can start this 2 instead of this. So that's why I told you, if and else, don't do that kind of if else comparison for regarding this. So no matter what, if I take, you can consider like I'm taking water right first, then I am taking this right, like land right then. So otherwise you can take land right first, then I can take the water right. Okay. So what I can know right now, if I know, like, if I do the land right, what is the minimum time I can do? At the 6. Okay. So if I do land right first, let's do the diagram. If I do land right first, what is the time I can what is the minimum possible time I can finish my ride? That is nothing but my 6 minimum possible time. Doesn't matter where can I start. I can start from here, I can start from here, I can start from here. Doesn't matter for me, isn't it? It is a 7 actually, don't forget it. So doesn't matter, I can take this or this. I can minimum one, right? So I can do the land first, then I can do the water first. So the thing is, why I am doing land first or water first? See, you have only one. Either you can write only one land right, and you can write only water right. Doesn't, like, there is no other options. You can write only once. Okay, only one right among all the rights in the case of irrespective of land or water. So anyway, either you have to write water first or land first. This is the two options only you have. There is no other option. See, there are, you can say there are two options, two land right, one water right. Then there are options. You can do land water, water land, or land water land. This kind of combination could be there. But here only two of combination is there, either land first or water first. So that's why I'm thinking of uh, this, like I'm doing the land first for I'm thinking. So this is done, this is the land is done. So now I'm thinking, should I write this one? So how could I do? Now this is simply a comparison as you did earlier. Think here, 6 I know, I'm minimum right is 6. Now I can do, I can take this one and I can compare. For, see here, now earlier we were comparing for each and every cases. Now I'm not comparing each and every cases. I am just calculated the time it is my, that what the time is needed, or when, at which time I'm going to complete my land right. So that is I'm doing right now. I am, so this is nothing but a single 6, this 2 6. So I'm not checking for each and every case. So entire how many six doesn't matter, how if they are all are six doesn't matter. For every case, I am checking this a single one. Then I am comparing with this thing. So it is a big of one rotation, big of n rotation. So I'm iterating this thing. I am done my land right, and I know what is the minimum time I have to spend in land right. Doesn't matter everything is a different, unique number or not, or it's the same number, same time is required or not. So I know the minimum time. I take in the minimum time. I'm considering my land first, and I'm considering right now how much time it will take. Okay, so now I'm comparing this one, this 3 5, because I know, like, compare, this is a 8 as well, doesn't matter, I told you. So right now I'm comparing this thing. Okay, so because it is a smaller, so I'm taking, or you can compare this as well. Okay, so land first, you can compare everything at a while. So if I take this one 6, so what is my result is, initially every time result is infinity, so all know that. So I'm comparing this one 1 and 80. Okay, I compared L first. So land takes 6 of time. Now, is it greater than my this one? Is this one is greater than my 6? No, because when I compare this one, so I'm not thinking of, like, I should have started this one. That's why I thought, don't start think of this one. I can start any point, anywhere. So this was, I am done. So this is less than my 6. So whenever I finish this thing, this is already started. So I can 6. What is the time is 18. So 6 plus 18, nothing but what, 24. So result is infinite, it becomes 24. Next case 6, then this case, so it is nothing but 3. 3 is already started. So in the between I am starting, so 6 is done. Then I am starting 5. So how much time? Time take 5 times the time. So 6 plus 5 is 11. So this is 11 unit of time. Okay, it's minimum the my current results it will be updated. Then I'll do what? I'll do this thing. So this 5 is again smaller than 6. So I'll take 6. 6 is the maximum. So between 5, because when I started, let's say I am riding this time and it is started. Okay, so this time after this I am writing this. So how much it will take? 6 plus 3, 6 plus 3, nothing was 9, 3 coming from this 3 because 6, then 5 is already started. Look, I have completed that 6 first, right? Then it will take the third. Okay, then what? Then 6 and 7, 6 and 7. What is the minimum? 6 and 7. What is the minimum? Okay, what is the minimum? 7. Sorry, what is the maximum? I am completely, let's say this one 6 or this one 6, whatever it is a 7. So it is a 7. So even though you can think of this, it is smaller, I'm start here. You can think this is smaller, I can start and I can do. What is the answer of this thing? If I start this, we will see what is the case. You can see like if you think you can now you can argue me like if it is 3 and 5, so I can start this one 3 plus it will take 8 amount of time. Then I can think 8 plus is 11 amount of time. But 3 here, see here, how much it will take. 6 I am done this one and now I am checking this one. So 6 I am doing, 6 I am doing. So 7 is the maximum, so I cannot write 6, it will be the 7 maximum of my land end time. This is land first, this is my land end time, maximum of and land end time and land water start time. Okay, so it is actually good thing. Instead of land first I can say land end time, LET, land end time. Okay, land end time is nothing but 6. So maximum of land end time and water start time. So this is my 7 plus what is the call? This is my 1 unit of time. 7 plus 1, this is nothing but my 8. So what is the minimum time I'm getting to finish land, first land, then water? Nothing but my 8. Okay. Okay. Let's solve the same thing. Let's do my land is done. So let's say I am visiting my water first. So okay, I forgot to update. So 11 was there. After that I got 9. So 9 it becomes 9. Then it will becomes 8. 8 is the minimum. Okay. Can I get anything smaller than that? Let's see. So earlier I am doing land first. Okay, now let's we are calculating for, let's say, water end time. Water end time, I know what is the minimum. I know minimum is nothing but this 8. All are 8s are minimum. So I know if I start my water right first, it will take in 8 unit of time to finish the water time. Okay, now I am comparing in each and every cases of land. So this is first. So 8 first, 8 plus this 2 is minimum, right? This 2 is minimum than 8. So the time I finish my water, right, that time it is started. So 8 plus 15, I'll just add maximum of this 8 and this 2. That is nothing but same. I'll take 15. So 15, 8 plus 15, how much it is? 5, 5, 20 and 3, 23. So is it minimum my result? No, it is not minimum my result. So I'll not update. Simple. So here if I start from 8 again, 8 and why 8? So this is my case 4. This 4 is less than my 8. 8 is the minimum. So that's why 4, 8. 8 plus how much of time? 8 plus 2, 10 unit of time. Minimum is what? Minimum is 8 right now. Minimum is 8. Okay. So then see what? So let's see. This is my 8. And this is my then coming this is 3 is less than 8, so 8 plus 3 is less than, so 8 I am taking. 8 plus 3, that is 11. 11 is smaller, not smaller than result, so it will be the smaller. Then what will be this case? So it is again, so 8 plus 4, it is 12. So again it is done. So again it is, now it is 17. 17 is larger, so 17 plus 1, 17 plus 1, that is nothing but my, let's say, what is 18 and 18, so it is obviously not small. So 8 is the case. This is the case if I do the my land right first and I'm doing then water right, and it is taking the smallest amount of time. Okay, hope you get it. Correct. So in this example, you can see then if I do the land right first, then water right, then it is the case. What is the possible cases? 4, 2, then 7, 1. I don't. They don't ask me the possible cases. I don't care of it. I can do this one or then this, I can do this one. So what could be the case then? What could be the case when land right can be kind of water right could be done? I just add one special case here. I'll add the special case here. Let's say 2, 1. Okay, 2, 1. So if you do the calculation, so if I do the land right first, then the calculation will be pretty much same, pretty much same. So that time it is 3, pretty much same. So what will be the case? Let's if I remove this part, this thing, because this calculation will be changed. Up to this it will be the same. See here, up to this it will be the same. Why? See here, I am obviously if I do the land right first, minimum case will be my 6. Okay, that's why 6 I'm checking for this one, this one, this one, this one. Now check another one, 6 for this one. Okay, if another one 6 for this one, then I can check one. Then my minimum one is 6, and this is nothing but 2. What is minimum? 6 is minimum. So sorry, 6 is maximum. That's why 6 plus how much time it is taking? It is taking nothing but one time. Okay, so it is a good example, or it's a good example or not. Let me wait. Let me give a good example. It's not a good example. Yeah, got a good example. Nothing but 1, 2, 1, 2. So here it is nothing but time is again 3. So yeah. So what is that thing? Here it is 6. I am taking 6 here. Then this is my 1. So obviously 6 is my greater. So 6 and time is 2. Time is 2. So that time it is taking what much? 8 amount of time. So you can see like, okay, 8 amount of time and this is the minimum currently. So I'll not update the result. Now what if I do the like water right first? So if that is the case, if I do water right first, so water and time, so minimum will be obviously this 3 will be the minimum. So in the 3 I'll compare this 3 with this 2. 3 is the minimum, so maximum. So 3 plus 15 it will take 18. Obviously it's not the case. Now I'll come here 3. 3 will be the here not 3 is the maximum, 4 is the maximum. See, 4 is the maximum. So if I do that 4 plus 2, that is 6. See here, 4 plus 2, 6. So if I do this right, then I can do the 6. So it's obviously minimum. It will update the 6. Okay. Then if I do this one, that then what will be the minimum? Water right is 3 and this is 3. 3 and 3 both are the maximum. Okay, 3 and it will take 3. So it will again 6. So it will the minimum. So after that, this one and 3 both are same actually. So 3, then 4, it is nothing but 7. So 6 is the minimum, it will not update. Then 3 and 17. 17 is obviously my maximum. So 17 plus 1, that is 18. So it is obviously not the case. So here, if in this case, if I do water right first, then my I can get the minimum time. So that depends. So that's why you have to first check on the one case of the left, sorry, not left, one case of the land right first, then water right. In the next case, I will do the water right first, then the land right. Okay. So in this case, if I write this kind of solution, let's say how to write the code for this kind of solution. Okay, let's write a function. So I have to check for both cases, right? So instead of writing two things again and again, let's find the solution, like a simple kind of generic term. So let's say function. Let's say my function is nothing but solve the problem. Solve. Okay. So first I'm getting a start time. Start. So start one. It would be any start. It could be my land right. It could be my water right. It could be anything. Start. Another one is what? Another one is my duration. Duration one. Okay. Another one is what? Start two. Start two and duration two. And duration two. So what I am actually checking? First, I am checking the minimum of I'm checking the minimum of fast case. It could be start one. Let's assume instead of ALR string like land rate, think of it as a water rate. And sorry, start one. And it's a water like it start two. So I have to find out what is the minimum duration in the fast case. Okay. So in the minimum, what can I do? Obviously, I can do, let's say, finish time of one, finish time of fast case. Let's say it is infinity. I can write a loop. So for how much time, for I equals to 0, I less than my length of start one dot length, and I plus plus, I and with the minimum finish time for the fast. So minimum finish time for the fast array, I have to find it out. Okay, my minimum array, I have to find it out. So in that case, I have to write this thing. So my fast time of 1 is nothing but finding the minimum of what? Finding the minimum of previous fast finish time, not fast time, finish time of 1, and my current case, that is current case nothing but start of 1 of I plus duration of I, du1 of I. Simple. That's how I can find the minimum of it. Okay. In the next case, so for next case, I am taking this one. I'm finding the minimum. So the thing what I actually doing, if I am finishing, I'm writing that finish time, what finish time is infinity. Then what I am doing, I am checking whether this is, I am adding is, whether this add is, if it's smaller than my finish time, then I'll update 17. Then I'm add it. If it is smaller than finish time, then I'll update 6. Now it is the added 6 is not smaller, well, I will not update. So this is 7, this is not smaller, I will not update. This is how I am doing the finish time calculation, correct? Okay, now I got this finish time, now I got this kind of calculation. This is nothing but I'm iterating each and every case, and I am checking what is the maximum, either my finish time or that start time, whatever is the maximum, I'm take that one. If 7, let's say yes, 6 is the maximum in this case, so I'm taking 6. Yes, 7 is the maximum, then 6, then that's why I'm taking 7. So this is what I'm taking. I'm comparing start time with the finish time. Then what is the maximum I'm taking and adding this duration. Correct? So that's what I'm doing. I'll do. For next iteration, I need another finish time of 2. It is also infinity. So I'll write another loop. So that's why for I equals to 0, I less than my start time of 2 dot length, then I plus plus. What I'll do taking the finish time. So okay, why I'm writing in this color? Okay, let me rewrite. Okay, so for I equals to 0, I less than my start 2 dot length, then my I plus plus. Okay, in that case, what I will calculate? I will calculate the min time, that is what is the maximum of that time. So maximum of that time plus, so finish time, not finish time 2, I'll calculate directly. Yeah, let's say my water end time, let's say end time end time will be what? End time will be my maximum of fast finish time, so finish time 1, and what could be my maximum? My current start time of this ride. So it could be my start 2 of I. What is the maximum? I will take this one plus this maximum plus that with I'll do duration 2 of I. At the end, I'll upgrade my finish time. So finish time 2 will be minimum of finish time 2 and this end time. You can write in a single line, but it will become more complex. That's why I'm dividing in these two steps. Otherwise, you can write this entire thing in these steps. Okay, so it doesn't matter. So at the end, this loops end, and this is nothing but my final finish time. This is nothing but my final finish time. So I'll return my final finish time ft of 2. Okay, this is what I am doing. Okay, so if I write to my solve function right now, well, not solve function, my actual function. If I have to write my actual function, just a minute. Okay, let's write what this function name I had given earlier. Okay, let's copy this one. If I have to write my actual function here, this is my function. So what I have to do, I have to simply call this thing twice. So first, I'll try to do my finished first. Let's say my land first. And for this, I'll solve. I call this solve function. Solve function of my first. I'll pass my land time. So that's why land rights. So let's say land first. What do we? After that, I'll do water first. So water first. That time I will solve. I'll pass water first. Water start time, water duration, and land start time, land duration. I'll do that. Okay. And after that, I'll I'll return what will be the minimum of return minimum of anything. This these two things. The minimum of my land first and get water first. Water first. Okay. Now that's all. That's all we have to do. That's all we have to do. So let's see what is the time complexity of this problem. See, this is also big O of nothing but n or m. N or m. Correct. And it is also big O of n or m. Why or m? When I am passing land first, then it is big O of n. When I am passing water first, then it is big O of m. So that's why it's a big O n or m. So at the end, it is nothing but this solve function takes big O of entire solve function. It is taking big O of n plus m. N plus m. Here also, it is also that's why it is a big O of n plus m. It is also big O of n plus m. So solve something like so time complexity is nothing but becomes big of n plus m, and space complexity, are you taking extra space? No. That's why big of 1. Okay. So there's the reason. There's the reason you can solve the problem. Okay. So earlier I actually give you an example. Like in the time, in most cases you are giving time complexity and space complexity are a kind of a trade-off. So if you have to increase the time, you have to sorry, you have to reduce the time, you have to increase the space. But this is not always the most cases. I give an example of how money and compared to the space complexity. You can think of this way. So if you think like the bus ticket and train ticket is kind of same to moving one station to another station. So obviously you will go for the train, right? It will be bus will be much more. There will be more traffic in the road compared to the railroad, right? So that's why sometimes you can do save your time without any extra space as well. This very particular thing is actually depends on my previous video. That's why I give you. If anyone can actually ask me this kind of thing, like as yesterday I said, like you have to always trade off. Not always. Most of the time, you have to trade off space. You have to, if you reduce the time, but not always. This is a good example of that. Okay, so this is the end of the topic. I guess you understand. And as always, if you find any video on this topic, sorry, I missed my dialogue. Okay, as always, if you find any mistake in this video, please let me know. So then I can learn or I can rectify. I am missing my dialogues so bad. Or as always, and if you find any useful information on this topic, please let me know so that I can also learn. Okay, thank you. Bye bye.